Hello, and welcome back to the 5.1 notes. This is part 4, and I want to talk about the next thing that we have to do with this, and that is what's called an initial value problem. And this is when we're going to be solving for C, okay? So, what you're given is you're given the derivative, and then you're given a point on the original function, and that's going to help us solve for C. So I'm going to go ahead and show you how to do that. And what we're trying to do is find the original equation that satisfies this condition, okay, the initial condition. So what I want to do is, first of all, write that I want to find my function f of x. And the way that I find my function f of x is to take the antiderivative of my derivative, which is 2x minus 5. So 2x minus 5 dx, okay? And so as a result, my function f of x is equal to 2x. Okay, I got to raise my exponent by 1, so I'm going to get x squared, and then I'm going to divide by my new exponent, and then minus 5x, and then plus c, all right? So let's go ahead and let's simplify this. 2 over 2 just gives me 1, so I just get x squared minus 5x plus c. Okay, and if you wanted to check to make sure that you have the correct antiderivative, then just go ahead and take the derivative, and you know that if you took the derivative, you get 2x minus 5. So we're good on that. But so this is my, and we're going to call this the general solution, okay? This is my general solution, okay? Or general equation, whatever. So this is general, okay? That's that plus c, okay? It could be anything, depending on what we have as initial condition. So what I have now is I have an x value, 0, okay? That's my x value. And then I have a y value of 4, okay? My function value. So what I'm going to do is I'm going to plug these values into my antiderivative and solve for c. I have an x and I have a y value, my function value. So let's go ahead and do that. So I know that if I plug in 0 into my antiderivative, okay, that's my x value, then as a result, I'm going to get 4, okay? And what this does is this allows me to solve for c, okay? And so I can just kind of just know that 0 squared is 0, minus 5 times 0, all of this is 0, so you just get c is equal to 4, okay? And so when c is equal to 4, then I can plug that back into my original general form and get a particular equation. So I get f of x is equal to x squared minus 5x plus 4, okay? And so this is my, what we would call our particular solution. And so the general one always has the c in it, okay? And particular solution is we have solved for c. Okay. So let's go ahead and let's take a look at the next one, number 78. And so what I want to do, it gives me the derivative, and I want to find the original function and solve for c. So I'm going to write this. I'm going to write that my original function f of x is equal to the antiderivative of 3x squared minus 1 dx, okay? So let's go ahead and take our antiderivative. So f of x is equal to, say, 3x. Okay, increase our exponent by 1, which is going to give me 3, and divide by our new exponent, which is 3, minus x plus c. Okay, let's go ahead and simplify this. So f of x is equal to x cubed minus x plus c. All right, and that's our function, okay? So this is my general solution. I'm just going to call it my general. And so then I want to use my initial condition here with an x value of 1 and a y value of 2. So I'm going to plug in 2 in for f of x, which is my y value, and then I'm going to plug in 1 for x. So I get 1 cubed minus 1 plus c, okay? And so I get 2 is equal to 1. 1 cubed is just 1 minus 1 plus c. This becomes 0, so 2 is equal to 0 plus c. So I know that c is equal to 2. Okay? So I'm going to take this, plug it back in for c here, and then just write my original function, f of x. And that's going to give me x cubed minus x plus 2. And this is my particular solution. Particular. Okay? So this is what we're looking for. All right? So let's go ahead and take a look at some applications of this. Why would we need to know this? And so what you've got here on problem number 83 is that you're given a velocity function. And you're being asked to find the position function. Okay? You have an initial position. And so we want to find the position function with the given initial position. All right? So let's say this, all right, my velocity is labeled by v of t. My position function, I'm going to call that s of t, okay? And if I wanted to find my position, given velocity, then I would take the antiderivative of my velocity, which is 2t plus 4 dt, okay? So as a result, let's go ahead and do that calculus. S of t is equal to 2t squared divided by our new exponent, which is 2, plus 4t plus c. All right, so I'm going to go ahead and do s of t is equal to t squared plus 4t plus c. Okay, we'll go ahead and simplify that. And so this is my general solution. All right. So now what I want to do is use my initial condition and figure out what c is. And this one's kind of simple because I'm plugging in 0 for t and then 0 for my position. So I get 0 is equal to 0 squared plus 4 times 0 plus c. So I end up getting that 0 is equal to 0. All of this stuff is 0 plus c. So I know that c is just equal to 0. Okay? So I'm going to plug 0 in for c, which is kind of nice. But I get that my position function, s of t, is equal to t squared plus 4t plus 0, and that's it. Okay? So that's all I got for that. All right? So that's my position function given a velocity function. Let's try another one. This one's a little bit tricky. But again, it's the same concept, okay? If I wanted to find my position function, then I take the antiderivative of my velocity function. So I get e to the negative 2t plus 4 dt, okay? So as a result, let's go ahead and just take this antiderivative. This is kind of tricky. This does involve a little bit of the chain rule here. And so if I were to take the antiderivative of e to the negative 2t, this is going to give me negative 1/2 e to the negative 2t plus 4t, okay, and then plus c. Okay, the reason why I multiplied by negative 1/2 is because if I took the derivative of this, okay, I'd have to use the chain rule and multiply by the derivative of negative 2t. And so negative 2 times negative 1/2 gives me 1, which is what I needed up here, okay? So you do have to sometimes think of the chain rule depending on the function, but the more practice you do, the better you get at it. So, but this is my general solution here, okay? And I want to use my initial condition to find out what c is, okay? So I'm going to plug in 2 in for my position, plug in 0 for t, so I get negative 1/2 times e to the negative 2 times 0 power plus 4 times 0 plus c. Okay, so 4 times 0, that just goes to 0. So I get this. I get 2 is equal to negative 1/2 times e to the 0 power plus c. Okay, and e to the 0 is just 1. So I get 2 is equal to negative 1/2 times 1 plus c. So I'm going to go ahead and add a half to both sides. So add a half to both sides. So I find out that c is equal to 1/2 plus 2. okay, which is going to end up giving me 5/2 for c. Okay, kind of doing some weird stuff there. But I'm going to go ahead now and just plug that back in up here. And so then we get that s of t is equal to -1/2 e to the -2t plus 4t plus 5/2. Okay, and that's my position function. Okay, and this is my particular solution. Okay? The last problem I want to do is to repeat that same process, but to go from acceleration to position. Now remember, acceleration is the second derivative, so we're going to have to do that twice. We're given an acceleration function, and then we're given a point on my velocity function, and then a point on our position function. So I'm going to go ahead and get started with this. I'm going to go ahead and start and say that if I wanted to find my velocity function, okay, then I would take the antiderivative of my acceleration function, which is just -32 dt, okay? So let's go ahead and figure that out, and that one's not too bad. So I just get -32 t plus c out of that, okay? And that's my velocity function. Again, this is my general solution. So now I want to use my initial condition here to figure that out. And so I know that at time 0, my velocity is 20. So I plug in 20 for my velocity, and I get -32 times 0 plus c. Okay, that just becomes 0. So I get that c is equal to 20. All right, and I'm going to go ahead and plug that back in up here. And so my velocity function, the one that I want to write, is -32t plus 20. Okay, and that's my velocity function. All right, now, but it wants me to continue this process and find my position. So I'm going to do the same process, but I'm going to find my position. So my position then, s of t, okay, is equal to the antiderivative of my velocity function. So -32t plus 20 dt. Okay, so let's go ahead and do that. S of t is equal to -32t squared, raise my exponent by 1, and then divide by my new exponent, plus 20t plus c. Okay? And so we can simplify this and write s of t is equal to -16t squared plus 20t plus c. And the initial condition that we had was that s of 0 is equal to 0. So I'm going to plug in 0 for t and 0 into my position. So I get 0 is equal to -16 times 0 squared, okay, plus 20 times 0 plus c. So I get 0 is equal to 0 plus c, so I just get that c is equal to 0, okay? And I'm going to plug that into this part right here, okay, because here's my general solution, okay? So then I know that my position function, s of t, is equal to -16t squared plus 20t, and then that's it, okay, because c was 0. All right, so this is my particular solution. This is what I'm looking for, okay? So let's go ahead and do one more of these. And we've got some trig problems, so it shouldn't be too terrible. But I'm going to go ahead and write that my velocity function, v of t, is equal to the integral of 2 cosine of t dt, okay? So I have to think, the derivative of what would give me cosine? So the antiderivative of cosine is going to be sine, okay? But I have that 2 out there. I'm just going to keep that there. That's a constant multiple. So I get 2 sine of t. Okay, if I took the derivative of sine, that's going to give me cosine. And then I need the plus c as well, okay? So if I plug in 0, this is my general solution, okay? If I plug in 0 for t, I get a y value of 1. I get a velocity of 1. So I'm going to go ahead and do 1 is equal to 2 times sine of 0 plus c. Okay? So as a result, sine of 0 is just 0. The y value in my angle measure is 0. So 1 is equal to 2 times 0 plus c. That just becomes 0. So 1 is equal to c. Okay, I'm going to plug that back in up here, and I'm going to write my velocity function as v of t is equal to 2 sine of t and then plus 1. Okay, and that's my particular solution for my velocity. But they want us to find our position, okay? So if I wanted to find my position s of t, then I would take the antiderivative of 2 sine of t plus 1 dt. All right, and so we have to ask ourselves the question, what's the antiderivative of sine of t? So the derivative of cosine gives me sine, okay? But if I took cosine, it's going to give me negative sine. So the antiderivative of sine is actually going to be negative cosine. So I'm going to write this as negative 2 cosine of t, and then plus t, and then plus my constant c. All right? And if you ever want to figure out if you've taken the antiderivative correctly, just take its derivative, and you should get what you started with down here. Okay? So this is my general solution. Okay? And I have the initial condition of my position is 0 when time is 0. So I'm going to go ahead and plug that in. And so I end up getting that 0 is equal to negative 2 times cosine of 0 plus 0 plus c. Okay? And so now I get this. I get that 0 is equal to negative 2. Cosine of 0 is 1. So negative 2 times 1 plus 0, I'm just going to leave that, and then plus c. Okay? C. So I get that 0 is equal to negative 2 plus c. So then I'm going to add 2 to both sides, and I get that c is equal to positive 2. So I'm going to go ahead and plug that back into my general solution to get my particular solution. So I get that my function, s of t, is equal to negative 2 cosine of t plus t, and then plus 2, okay? And that, my friends, are initial value problems with some applications. So I hope you enjoyed this. I had a great time making this video, and we will see you soon. Thanks. Go ahead and get started on the homework, please.